Hello, everybody. In this video, I'm going to go through this proof here, which is a little bit different from other proofs we have seen before. It's given that AD and BC are two parallel segments, and AB and CD are two parallel segments, and we're going to prove that AB and CD are congruent. So let's kind of think about this here. We we have these parallel sides, and notice if you hover over these in delta, right, AD and BC are parallel. Those are the two orange here. And then if you switch AB and CD, those are the ones we want to prove that are congruent. So how can we get there? I want you to notice that we have some triangles here. So if I can maybe show that these triangles are congruent in some way, where AB and CD are corresponding parts that are congruent, then I would have all the information I need based on what's here. So how could I do that? We have to use what we know about parallel lines, right? And so look at these parallel lines here, BC and AD. These two parallel lines, and I'm going to extend them actually a little bit further. BC and AD, they are being intersected by a transversal AC. And we know that these alternate interior angles are congruent. So how does that help us? I can say that angle BCA is congruent to angle CAD because they are alternate interior angles that are formed when two parallel lines are cut by a transversal. And that's one set of angles in each of these two triangles, right? So let's start with that. I'm going to start by saying that two angles are congruent. So angle X is congruent to angle Y, and our angles here are BCA and CAD. Our reasoning, let's see, reflexive, transitive, substitution, corresponding parts, no, we're not there, vertical angles, if two angles are complements, if two angles are supplements, all right angles. I'm looking for like alternate interior angles or something like that. Oh, parallel lines. Oh, I wonder if I have to say that first. No, I don't think so. I wonder if I can say Oh, maybe that isn't what we want. Oh, it is the one I want. I just didn't read it right. Huh. Parallel lines cut by a transversal form congruent alternate interior angles. I would write that as the alternate interior angle theorem. That's a lot easier to me. But y'all might disagree. Let's see if it's right. What? Okay, now we also have those other sets of parallel lines. And that arguably, parallel lines, transversal, it should have some alternate interior angles as well. So let's kind of think about what those would look like. So we have side AB and side CD, and they are cut by this transversal AC. So the alternate interior angles that are formed are in towards the shape. So that would be angles B, and green's kind of confusing, so there's already green there. That would be angle BAC and angle DCA. So these alternate interior angles are congruent. But let's also set that up. So angles BAC, oops, and DCA are congruent by the same logic. These parallel lines, and notice how I typed parallel lines cut by a transversal form congruent alternate interior angles. Let's try it out. Bam. All right. So how is this helpful to us? Let's think now about the two triangles we have. So I'm going to kind of pull them out to the side. I have triangle ABC and triangle I'm going to take it, I'm going to flip it. AC is still the long side, and then we have D, right? So looking at the first triangle at ABC, I know that A is congruent to C in the opposite triangle. So those two angles are congruent. And I know that C in our first triangle, ABC, is congruent to A in the opposite triangle. Just matching up what's in the diagram. So I have two angles. This seems like it's begging to be proved that they're congruent. These two triangles are congruent by angle, angle, side, or angle, side, angle. So which one makes more sense here? Well, thinking about the triangles that we have, I know that they both share this same side AC, which is congruent to itself. So I'm going to say that this side AC is congruent to, I'm going to say CA, because A and C are congruent in the opposite shapes. So either way should work though. And the reasoning here now, if something is congruent to itself, that's the reflexive property. Boom. All right. Now, there we go. I'm gonna say that maybe wasn't the best call. Just getting rid of this would be better. So now we know these sides are congruent as well. Super important. AC is congruent to AC. So I can say these two triangles are congruent, right? I can say that triangle ABC is congruent to triangle, and I have to set this up right. A is congruent to C, so CDA. Because I have an angle, and let me use my little, there we go. I have an angle, I have a side, and I have an angle between these two triangles that are congruent. So by angle, side, angle congruence, I can say the two triangles themselves are congruent. So triangles. Triangle XYZ is congruent to triangle TUV. I need to say the triangles themselves are congruent first. And it is ABC is congruent to CDA. And our reasoning here is angle, side, angle. We have two angles and the side in between, that shared reflexive side. Oh my gosh, I love it so much. Okay, now we are almost done. Remember, our goal is to prove that AB and CD are congruent. Well, we know that these two triangles are congruent, right? So are AB and CD corresponding sides? Is AB congruent to CD? Think about it. If you start at A, you're starting at the green and going up to B. So if we did the same thing in the opposite triangle, that would be like it's starting at C and going up to D. So AB is congruent to CD, or they match up, I should say. They're corresponding. So they are congruent. They are corresponding parts in two congruent triangles. So our statement is going to be that these segments are congruent. Segment AB is congruent to segment CD by the corresponding parts of congruent triangles are congruent. The CPC TC. All right. And now we can submit. So this one takes a little bit of piecing together, especially with those two sets of parallel lines. But with practice, you can start to kind of play around with these proofs. It takes some trial and error. I definitely didn't learn this overnight. So please send me screenshots of problems as you encounter them. Come to my office hours. I would love to chat.